So today we're doing section 9.2. Our purpose statement is the student will be able to write and analyze piecewise functions. A piecewise function is a function that is a combination of one or more functions. Example would be if you go to buy a drink at a restaurant. For the first drink, let's say it's $2 for a large pop. And so from 0 to 1, you stay there at $2. But if you buy 2 pops, then it goes and skips up because there's no in between. Everything from 1 to 2 is $4. And it just increases like that. So the graph's separated into parts. And so sometimes those functions change for each part of the graph, which we'll take a look at in a second. The most common one you'll see is a step function, which is the type of piecewise function that is a constant for each interval of its domain, which is what this is, because you can see as you got 3 drinks, we go up to $6. And so by doing this, it looks like steps. And so that's why it's called a step function. So a lot of what we're going to do today is by looking in the book. So I'm going to put the book up on the screen so we can go through their examples. So on this first example, it says create a table and a verbal description to represent the graph. So you can see here we've got the movie tickets, and for for your age, from any, it looks like, since this is 15, it's somewhere in here, 13, 14, that if you're 13 or 14 or less, it's $5. And then once you turn 13, it looks like, so I'm going to say 13 up to 50, then they charge you, so it'd be $9. And then from 50, once you turn 50, you have your senior discount, and so it drops down to $6.50. And so the table looks like this. For the age, they did 0 to 12 again. You're just guessing here because you can't tell for sure. So whether you put 0 to 12 or 0 to 13, the price is $5. And then from 13, I guess it was 54, it's $9. And then at 55 plus, it goes to $6.50. And so that would be a description. And so the verbal description, it says, use the domain intervals and the prices from the table. Movie tickets are $5 for children ages 12 and under, $9 for people ages 13 to 54, and $6.50 for seniors ages 55 and older. And so you just describe what happened in the graph. So here's how a step function is read without the graph. And so these are just different to work with. As soon as you understand it, it becomes pretty easy to do these. So the way this is read is the function f of x. We have 3 different rules here. The first rule is if x is less than or equal to 0, we're going to use this rule, which in this case is just the constant -5. And from 0, greater than 0, and less than or equal to 3, we're going to the value 4. And if x is greater than 3, then our value is 12. So these are pretty easy because you just have whatever rule you use, that's the value you plug in. So they ask us to find out the function for x equals -2 and x equals 5. So the first thing you do is you take your value of x equals -2 and you decide which rule does it go into. Well, since -2 is less than 0, we would use this rule, and so our answer is -5. So f of -2 equals 5. And for x equals 5, it's not less than 0, it's not between 0 and 3, it is greater than 3, so I use this rule, so f of 5 is 12. So it makes it pretty easy. If it was, now, one thing you need to be careful of, if it's 0, you wouldn't use this one because x is greater than 0, so I'd have to use this one because it can be less than or equal to 0. So here's a more typical one where you have 2 rules. One for if x is less than 5 and one for if x is greater than or equal to 5. And so what you do is you go again, we're going to use these same values for x. So x equals -2, and you decide which rule does it go into. Is it less than 5 or greater than or equal to 5? Well, -2 is less than 5, so I use this rule. So that tells us to plug -2 in here for x. 3 times -2 is -6, plus 4 is -2. So g of -2 is -2. For x equals 5, well, that would be, it's not less than 5, so it goes in here, 5 or greater. 5 squared is 25, minus 3 is 22, so g of 5 is 22. And then we've got some examples here to go through on the bottom there. So it says, here is our function f of x, and we want to find the values for -1 and 3. So again, first thing you ask yourself is which rule does -1 go in? Is it less than -3? No, it's greater than that. Is it between -3 and 6? Yes. So we use this rule, so it would be 15. So I'd write my answer as f of -1 equals 15. X equals 3. Again, that would also be between -3 and 6. So again, my answer is 15, so it'd be f of 3 equals 15. Again, here's more where we have rules to plug it into. So -1 is less than 0, so I use this rule. So -1 squared is 1. 3 times 1 is 3, plus 1 is 4. So f of -1 would equal 4. Plug in 3. That's greater than 0. So 5 times 3 is 15, minus 2 is 13. So f of 3 equals 13. So you just take the value of x, find out which rule it fits into, and then plug it into the equation or expression and find the value of that. They're going to ask you to graph some functions here at the bottom. So the first one says we've got the function f of x. If x is less than 2, it's -4. If x is greater than or equal to 2, then it's 4. So we graph the first one first. So we go to 2. 2 is, it's an open circle because it's got to be less than that. So we put an open circle because that means we're to start there but not included. And we're at -4, so it would just be a horizontal line to the left. And then at x is greater than or equal to, we put a closed circle at 4, and it would be 4 all the way to the right because it's that constant. Where it gets a little bit tricky, f of x or g of x equals 3x plus 8 if x is less than negative or equal to 3. -2x if x is -3, x is greater than -3 and less than 1, and if x is greater than or equal to 1, we use that third rule. So I'm going to write that up here so you can see how you would do that. Don't know what that is. So let's write that expression up here. G of x is equal to 3x plus 8 if x is less than or equal to -3. -2x if from -3 is less than x is less than 1. And then x squared minus 3 if x is greater than or equal to 1. And I'm going to show you two ways you can do this. The first way So the first way, for those of you that are visual learners, this might help you or might make it a little easier for you. I wouldn't do it this way, but you can do it either way, and I'll show you both ways. So let's take this first one. Okay, well remember, this is really your y equals 3x plus 8. So it's in slope-intercept form. So this crosses at 8 and has a slope of 3. So that would be up 3 over 1. Or you could go down 3, left 1. Down 3, left 1. Down 3, left 1. So this graph would look something like that. Okay, that would be the whole graph. But here's the thing. We only want to go from when x is less than or equal to negative 3. So we only want to use from here this way. So the rest of this now I can erase because I don't need that. Okay? Then I take the second part of it. Actually, so I wouldn't need that part of the graph. It would just start at negative 3 and go this way. So now on this one, again I'm using, this is my y equals. And let's do this one in green. So I plug in negative, my y-intercept is 0, so it would cross here, and it has a slope of negative 2. So I go down 2 over 1, down 2 over 1, up 2 over 1, up 2 over 1. And it looks something like this. It would go forever like that. That would be the whole graph if I just asked you to graph y equals negative 2x. But again, I only want that graph from between negative 3, that's an open circle at negative 3, and it's an open circle at 1. And so I wouldn't need the stuff outside of that. My graph doesn't go outside of that section. And then the last one, we'll do that in black. Again, this is y equals. But this is a parabola. And if you remember your parabolas, this would shift it down 3. So it would be here at, and then it goes over 1, up 1, over 1, up 1, over 2, up 4. And so it would look something like this. But again, I only want it at starting at 1, which puts it here. That'd be a closed circle. So it kind of filled in that circle that was there. And I wouldn't need this part outside of that. Okay. I would only need that portion. So this is one way to do the graph. You just graph them completely and then erase the parts that are outside of the limitations of x. Now, the way I would do it is I just take the graph, and again we'll do that first one in red. I just start with this point and I plug it in. Negative 3 times 3 is a negative 9, plus 8 is a negative 1. So at negative 3, I'm at negative 1, and it would be a closed circle. And then my slope is 3. Well, now remember, that would be up 3 over 1, but I'm not going to the right, I'm only going to the left. So I have to go down 3 over 1. And so this graph would look like that. Then the second graph, again we'll do in green. I plug in negative 3. Negative 2 times negative 3 is at 6. So it's negative 2, I'm at 6. And plug in 1. Negative 2 times 1 is a negative 2. And these are both open circles. And it's a straight line graph, so I would graph in between. And then the last one, it's a quadratic, so I know that's going to be a curved line. Again, we'll do that in black. So we plug in 1. 1 squared is 1 minus 3 is a negative 2. So I'm at 1, negative 2, which goes in this spot that's open. I just fill it in because the black part's going to fill that in. And then I plug in 2, because it's going to be curved. That would be at 2, it would be at negative, or at 1. And so I know that's going to be a curved line, so I would curve it. And so now I've got my graph. The red is for the first part, the green for the second part, and the black for the third part. So you just break it down into its parts. You will have some story problems. Take a look at this. So this is an example of a word problem that they're going to ask you to graph. And it says, David is completing a 100-mile triathlon. He swims 2 miles in 1 hour, then bikes 80 miles in 4 hours, and finally he runs 18 miles in 3 hours. Sketch a graph of David's distance versus time. So we're doing distance on this side and time on the bottom. And that gives us the rate that we look at the rate he's traveling. So distance, remember, distance equals rate times time. So the rate would be the distance divided by the time. So 2 divided by 1 is 2, 80 divided by 4 is 20, and 18 divided by 3 is 6. And so then we can graph that. From 0, 1 hour, he only went 2 miles. Then from 2 miles to 82 miles, he was going, we go that way, and then it flattens out again because he goes from the 5-hour mark to the 8-hour mark. He only goes 18 miles. And so you can see, it's easy to tell by this when he's going the fastest, obviously when he's biking. He's going faster when he's running than he's swimming. All right? So as we go to write the function for this, the function rule, you can see that we've got 2t for 0 to 1 mile. We put in the 1 hour and he's gone 2 miles. Now it gets a little tricky as you get to these other ones because we know that after 2 miles, since he's going 20 miles per hour, he's only going to be 22 miles. But we know that at the speed, it's 20 miles per hour times t, but then we have to subtract 18 because he's not starting at 1 hour. He's starting, this is the 1 to 2 hour slot. And so if you put a 2 in here for how many hours he's been going, you'd be 2 times 20 is 40, and we have to subtract 18 to get to that 22. The same thing happens here. We know that his rate is 6 times t, but again, he's gone, when we look at this, he's gone 82 miles when we start here. And so he's got to be, after 1 more hour, he's got to be 86 miles. And so if you put 8 in here, if you put in, he's gone 5 hours. When you put in 6, you get 36. So you have to add the 52 to get to 82. So you have to do some work with those equations to get it. So you have to be careful on that. So your assignment. Page 666, numbers 9 to 29, the odds. So you just have to think about this. Be careful that you take your values of x, find the rule that it goes into, and then use that function to find the value. And then make sure, like if you're finding x equals 2, remember you're going to write your answers as f of 2 equals, and then when you plug it into the rule, you'll put the value that you get out. So good luck on that.